Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Now, your op-amp can be converted into different types of circuits. And in your syllabus, we learn about 3 types of circuits. One is called a comparator. One, you use it as an inverting. The second one is an inverting amplifier. The third one is a non-inverting amplifier. So there are 3 different types of circuits. And the way you connect them is very different. And your formulas are also different. So you cannot interchange the formulas because each of them have a special formula. So for a comparator, now why is it called a comparator? That means what the op-amp does is it compares the 2 voltages that you give it to the 2 inputs. So remember, these 2 are your 2 inputs, these are your supplies, and this is your output. So your 2 inputs here, both you give it a voltage, and what you will do is the op-amp will compare the voltage. How will it compare the voltage? It subtracts the voltage V plus and the voltage V minus. That's what it means by comparing. So it takes the value of V plus, subtracts the values of V minus, and then it will produce an output. But you must understand, the op-amp doesn't like take this voltage, add energy to it, and then comes out. It's not like that. What the op-amp does is it reads the difference here, and then produces a new output from the supply. That means it doesn't use the energy here and add to it. No, it's just that it sees what is this, and then from the supply it creates the output. So that means all your output actually comes from your supply. It doesn't have anything, it doesn't draw the energy from the input one. You understand? So what I mean is this, if you look at the example here, if this is a positive and negative supply is positive 9 and negative 9, and if this is 1.4 and this is 1.3, so if we substitute into this equation for a comparator, so the comparator must have this equation, V out equals to 10 to the power 5, which is the open loop gain. So open loop gain for DC voltage is 10 to the power 5. If it is AC, then it will follow the graph in the later part, the one I showed you, it will be like this. So where the gain versus frequency, this is up to 7 Hz. So up to 7 Hz, that means DC and AC up to 7 Hz, the gain is 10 to the power 5. Anything bigger than 7 Hz, the gain will drop. So since we're using DC, so how we know this is DC? Because they didn't mention the frequency. If you've got frequency, then it's AC. Alright, so since it's just 1 voltage, it's DC. So you substitute the 1.4 here, 1.3 here, that's the difference. Then you multiply by 10 to the power 5, which is the open loop gain, and you'll get 10,000 volts. So by right, it must produce 10,000 volts. But because all your output comes from the supply, and the highest voltage you have at the supply is positive 9, it cannot produce 10,000 volts. It wants to, but the highest it can produce is only 9. It's like, this is what you eat. This is what you shit. Can you shit more than you eat? You can't, right? You try, but you can't. Right? So the most is everything you eat, everything comes out. So therefore, you try to produce 10,000, but you only manage to produce 9, and then that's it. So there is no question about where is the lost 9,991 volts. Where did it lose? Nothing. You don't even get to produce it. You only get to produce 9 volts. That's called saturation. Do you understand? So another example is this one. So if I replace this value here with positive 6 and negative 6, so let's say it's positive 6 and negative 6. And my V plus is 3.652, V minus 3.654. You substitute in the equation, you get negative 200, right? What output will you get? Negative 6. Because you try to produce negative 200, but your supply is only maximum, because you're looking at negative, so you must look at negative. The biggest is negative 6 only. That means magnitude, the highest negative you get is negative 6. So you can only produce negative 6 volts. So that is called saturation. you will notice that for comparators, it tends to saturate very easily, which is a real characteristic of a comparator. Why? Because your gain is very big, 10 to the power 5. So 10 to the power 5 multiplied by any small number also saturate. That's why you notice the difference here. It's only 0.002 right now, and still saturates. So if you don't want it to saturate, what is your maximum difference? We look at the next slide. So now let's say you don't want it to saturate, and we have this example here where you have this op-amp. So I just draw for you. Let's say your positive supply and negative supply is positive 15 volts and negative 15 volts, okay? And this is your V out, and these are your two inputs, okay? Your V minus and V plus. Now, what is your maximum difference in order for you not to saturate? So since the formula is V out equals to 10 to the power 5, V plus minus V minus, and what is the biggest V out you can get? Isn't it 15 volts? So you substitute with 10 to the power 5, V plus minus V minus. So the maximum difference will be 150 microvolts before it will saturate. That means if you are using positive 15 and negative 15 volts supply, the maximum difference between the two of these must be 150 microvolts. Anything bigger than this, sure saturate. So you see from the graph here, so this graph is how the V out varies with the V in. So this is actually your V in. In the diagram they use V plus minus V minus. So your V in is actually your V plus minus V minus. So what will happen is this. Any difference bigger than 150 microvolts will saturate. Any difference bigger than negative 150 microvolts will saturate at negative 15. But in between, it won't saturate. So the gradient of this graph, do you realize, is what? Gradient will be equals to V out over V in, which is also the definition of gain. So the gradient gives you your gain. Do you understand now? Because for all op-amps, your gain is always defined as what? Whether whichever circuit you use is always the ratio of V out to V in. Do you understand? Okay, so this is how you know. So in other words, if let's say the supply is 12 and negative 12, then what's the maximum difference before it saturates? 120 microvolts. If it's 9 and negative 9, 90 microvolts. So when you're doing your calculation, you don't have to show the saturated value. For example, let's say you have the V plus as 1.5 volts. V minus is 1.3 volts. What's the difference? So will it saturate now if you're using 15 and negative 15? So you don't even have to show the non-saturated value like 10,000 or 15,000, 100,000. You don't have to show that. Straight away you write the saturated value. V out is positive 15, that's it. So you can show the calculation as like V out equals to 10 to the power 5, 1.5 minus 1.3, but straight away you write 15 volts. Saturated. You don't have to go and show the 0.2 times 10 to the power 5, which you get 20,000, on all this, no need to show. Alright, you understand what I'm trying to say? You straight away write down as 15 volts. Okay?
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.